Hey guys, welcome back. Today we're going to work on identifying proportional relationships in graphs and in tables. So today's objective is that you will be able to identify proportional relationships by graphing and from tables. So our first problem for today says Christina's space shuttle crew accidentally left her behind on a mysterious planet. She soon realizes that her body is aging much faster on this planet than it did on Earth. After 3 weeks on the planet, Christina's body has aged 3 years. After 5 weeks, her body has aged 5 years. In this relationship, X represents the number of weeks Christina spends on the planet, and Y represents the number of years she ages. So we are going to graph 2 points for this relationship, and then we'll draw a line between those to see where it extends to. Okay, so we need to go up here. First, we need to be familiar with our axis. Okay, so we've got this one down here along the bottom, which you all should know is your x-axis. And then we've got one over here on the side, which you should know is your y-axis. Okay, so we can see that our x-axis is labeled weeks and our y is labeled years. So it tells us that after 3 weeks that our body had aged 3 years. Okay, so we're going to graph that point. So we're going to start down here at the origin, which is at 0, and we're going to go over to 3 weeks, and then we're going to go up to 3 years. So that point is telling us that in 3 weeks she had aged 3 years. It also tells us that after 5 weeks she had aged 5 years. So we're going to start at our origin again. We're going to go over to 5 weeks, and then we're going to go up to 5 years. Now, should get you a straight edge for this. I'm going to try a straight edge and see how well it will do with me writing on this. And then you're just going to connect your points. Extend that line. And it's okay if it goes out of the graph or goes a little further. That's okay. So to know if a graph is representing a proportional relationship, it has to do 2 things. The first thing is it has to be a straight line. That means no curves in it. And the second thing means it has to pass through the origin. So the origin of a coordinate plane is this point right down here at 0, 0. Okay, so according to the graph, do X and Y have a proportional relationship? So you need to ask yourself, is this line that we have just graphed, is it straight? Does it have any curves in it, or is it straight? Well, it looks pretty straight to me. And then secondly, does it pass through the origin, that point of 0, 0? And it does indeed pass through the origin as well. Now remember, it can't have just one of those. It has to have both. It has to be a straight line and pass through the origin, which this graph does. So according to this graph, X and Y do have a proportional relationship. Okay, in our next problem, it says Dalton really wants to see his favorite band, LOL, in concert, but he doesn't have enough money saved up to buy a ticket. He decides to earn some extra money by mowing his neighbor's lawns. After Dalton mows 2 lawns, his savings grows to $20. After he mows 4 lawns, his savings grow to $30. In this relationship, X represents the number of lawns Dalton mows, and Y represents the total amount of money in dollars he has in savings. Let's look first at what it's telling us about the problem that we're going to graph. So we know that when he mows 2 lawns, that his savings grew to $20. And then after he mowed 4 lawns, it grew to $30. Okay, we're going to need to graph those. Okay, let's graph those. So 2 lawns, so I'm going to cross my x-axis to 2, and then that was $20. So it's going to be about right here. And then after he had mowed 4 lawns, his savings grew to $30. Find you a straight edge and connect those points. Remember, it's okay if you extend it beyond the points. So, according to this graph, do X and Y have a proportional relationship? Again, you have to ask yourself, is this a straight line? Does it have any curves in it, or is it straight? Well, this one is straight, but it also has to meet the second criteria. Does it pass through the origin? And as you can see, this particular line is not going to pass through the origin down here. Down here is the origin at 0, 0. So that line is not passing through the origin. So if it doesn't meet both of those, a straight line and through the origin, then it is not representing a proportional relationship. Let's give you a chance to try this one. Go ahead and pause your video so that you can attempt this problem on your own. Over the summer, Livingston Science Academy renovates its building. The Academy's principal hires Tiana to lay new tile in the main hallway. To cover the first 2 feet of the hallway, Tiana needs 6 tiles. To cover the first 3 feet, she needs 9 tiles. In this relationship, X represents the length of hallway Tiana covers with tiles, and Y represents the number of tiles she needs. Graph 2 points for this relationship and the line passing through them. So we know that she needs 2 feet and 6 tiles, and 3 feet, she needs 9 tiles. So let's graph those points. So 2 feet, so I'm going to go from the origin on my x-axis over to 2, and then I'm going to go up to 6. And then I'm going to go over to the 3 for 3 feet and up to 9. Go ahead and take your straight edge and connect those points. So, according to the graph, do X and Y have a proportional relationship? Is your line straight? Does your line pass through the origin? If you said yes to both of those, then yes, the graph does represent a proportional relationship. Go ahead and pause your video so that you can try this one on your own. Maureen likes to make lemonade using the lemons from her grandmother's trees. She needs 8 lemons to make 2 pitchers of lemonade, and she needs 20 lemons to make 5 pitchers. In this relationship, X represents the number of pitchers of lemonade Maureen wants to make, and Y represents the number of lemons she needs. Graph 2 points for this relationship and the line passing through them. So again, it was 8 lemons, and 8 lemons is on your y-axis, so you got to be very careful with that. You don't know which one it's going to give you first. So 8 lemons and 2 pitchers. Okay, so I'm going to go over 2 pitchers was 8 lemons, and 20 lemons was 5 pitchers. So over to 5 pitchers and up to 20 lemons. And then go ahead and use your straight edge to connect those 2 points. Ask yourself, is that a straight line? And does it pass through the origin? If you answered yes to both of those questions, then your graph does represent a proportional relationship. Now let's look at proportional relationships in tables. So as you can see in this question, there could be more than one correct answer. So both of those tables could be correct, so be very cautious with that. So we're going to select the table or tables that shows the proportional relationship between x and y. And I'm going to go ahead and introduce to you all what we call y over x, which we will use in some of our future lessons. So y over x. That tells us what our constant is. Any graph or table that has a constant, if it has a constant, then it is proportional. So that's why I'm going to go ahead and introduce that to you. So in this first table here, we'll call this one table 1 and this one table 2. In table 1, when we do y over x, well, our first y value is 2 and our second one is 5. And then if we go on down that table, we have 4 over 10. But you'll notice if you simplify 4 over 10, you can divide both numbers by 2. And 4 divided by 2 is 2, and 10 divided by 2 is 5. And if we do the last one in that table, we get 6 over 15. And if we simplify that, we would divide by 3, and 6 divided by 3 is 2, while 15 divided by 3 is again 5. So every time when we simplified those fractions, when we done y over x, we end up with the same number. If you end up with the same number every time, then that means that it is a proportional relationship. This also is telling me that if I take my x value, like 5, and I multiply it by 2/5, then I'm going to get 2. And if I multiply 10, which is my x value, by 2/5, I'm going to get 4. And 15 by 2/5, I will get 6. Now, that table is a little bit harder to see because you're having to do that y over x, when sometimes it's going to be really simple. Let's go ahead and look at our second table. So we had, again, you're still going to use y over x, so your first y value is 2. And your x value is also 2. And we know that 2 divided by 2 is 1. In our second table, we have 5 over 4, which is equivalent to 1 1/4. And then we have 10 over 6. You can change that and say that that is 1 4/6, or 1 2/3. Or you could simply simplify that 10 over 6, dividing by 2, which would give you 5/3. And if you'll notice each time, these numbers are not the same. So that means that table 2 does not represent a proportional relationship. So the only one that represents a proportional relationship is table 1. Okay, let's look at a second one with tables to see if it is a proportional relationship. Don't forget, we're still going to use that y over x. And in our first table, our y value, again, this is our first table and our second table, our y value is 2 over 3, which cannot be simplified. And then in that same table, we have 8 over 12. We could simplify 8/12 by dividing by 4. So 4 would go into 8 2 times, and into 12 3 times. And then we have 10 over 15. And both of those numbers are divisible by 5, which leaves us with 2/3. So when we do y divided by x and we get the same number every time, That tells me that table 1 is proportional. However, we still need to check table 2. Again, we still do y over x. So we have 1 over 5, and we have 2 over 10, which needs to be simplified by dividing by 2. And 2 divided by 2 is 1, and 10 divided by 2 is 5. And to check the last one in table 2, we have 3 over 15, and both of those are divisible by 3. 3 divided by 3 is 1, and 15 divided by 3 is 5. So every time, once we simplified y over x, we had 1/5, which means table 2 is also representing a proportional relationship. Pause your video and complete this problem. We have y over x, and in table 1, that is 2 over 1, which is the same as the whole number 2. We have 8 over 4, and 8 divided by 4 is 2. And 10 divided by 5 is also 2. So we have the same number every time. That tells me that table 1 does represent a proportional relationship. Now let's look at table 2. We're still doing y over x, and we have 1 over 4, which cannot be simplified. We have 4 over 8. Both of those are divisible by 4, so that simplifies to 1/2. And then we have 7 over 12. 7 is a prime number, so 7 over 12 cannot be simplified. So we have 7/12, 1/2, and 1/4. Since all three of those are not the same number when simplified, then table 2 is not representing a proportional relationship. Okay, let's try another one with proportional relationships in tables. Go ahead and pause your video and try this problem. So we're doing y over x, and in table 1, our first y value is 3 over 2. In our second one, we have 6 over 4. 6/4 can be simplified by dividing by 2. 6 divided by 2 is 3, and 4 divided by 2 is 2. Our last value is 9 over 6, which can be simplified by dividing by 3. 9 divided by 3 is 3, and 6 divided by 3 is 2. So every time when we simplified y over x, we got 3/2. So table 1 does represent a proportional relationship. Now let's check table 2. We're starting out with y over x again. We have 3 over 5, which cannot be simplified. We have 6 over 10, and both of those numbers are divisible by 2. So 6 divided by 2 is 3, and 10 divided by 2 is 5. And then we have 9 over 15, and both of those numbers are divisible by 3. 9 divided by 3 is 3, and 15 divided by 3 is 5. So we end up with 3/5 every time. So that means that table 2 also represents a proportional relationship. Okay, we have finished today's lesson. If you would, please go to your forms back in your class notebook and click on the exit slip link. Please complete your exit slip prior to doing your assessment. So complete that exit slip, kind of self-assess yourself and make sure you're on the right track. Then you will go to your assessment link and complete your assignment. Thank you.